So thank you all so much for joining us today. This is our kickoff workshop for the Data Storytelling Challenge. So this is a new project launched by York University Libraries today. I'm Alex Wong, the Data Visualization and Analytics Librarian, and I'm joined by my colleagues Lana and Ted. And maybe if you don't mind introducing yourselves very briefly too.
I'm the Makerspace assistant, also working at York University Library, Markham campus.
And I'm Ted Belke. I'm the digital engagement librarian working at the Markham campus in the library as well.
Thank you both. We have our cameras on right now, but we'll be turning them off as we're talking just so that the recording is free from our faces so that you can get the full effect of the slides, since the slides are really the star of the show today. But we'll go ahead and share our agenda next. So this is what we'll talk about in today's last 50 minutes of the hour. We'll introduce the challenge, kind of give a brief overview of data visualization and data physicalization, talk about the challenge logistics, like the benefits, timeline, and eligibility. We'll go into the theme, the Landstar machine, and then some data sets that we suggest. Though students are invited to create their own or find their own as well, and we have some suggestions there too. Then we'll go into talking a little bit about the process of making a data visualization or physicalization. Lana will be able to show what she's created for this workshop. And in fact, the designs that you've been seeing for all of our storytelling challenge, like the shape at the top right corner, are created by Lana for today's workshop for this workshop and challenge. And then we'll go into how you can create a data visualization or physicalization yourselves too. We'll go into more supports for the challenge. So the challenge has a lot of library resources and makerspace workshops and orientations, as well as folks like myself, Ted and Lana, who are available to act as consultants on a student's project. And then finally, Ted will wrap us up with the exhibition details, like the exhibition logistics and planning. So to introduce the challenge in data visualization, we first want to kind of level set with data storytelling. So data storytelling is really the ability to effectively communicate insights from a data set using narratives and visualizations. It can be used to put data insights into context for and inspire action from your audience. And that's just a quote from a Harvard Business School page, but I thought I liked this one. Oh, sorry, Ted, if we could go back one slide. Because there's three different components of it, the data, which is the foundation of the story, the narrative, which is our ability to provide insights, context, and any follow-up actions, and then the visualizations, which really can communicate a clear and memorable narrative through the use of graphics. So if we go ahead, Ted, and share this example. So this is a table here from CDC. It's essentially a type of visualization too. It's a table, but it's not the most colorful or the most easy to read type of visualization. So if instead we think about how we've got our data and we've got our visualization, but it doesn't really have much of a narrative. We've got our table title, which just says number and percentage of foodborne diseases, outbreaks, and outbreak-associated illness by food category. It's telling us what the table contains in it, but it's not giving us a real narrative or any clear insights. We would have to be drawing those conclusions ourselves by looking and reading this table. But in comparison, if Ted, I could ask you to click, we were to look at this visualization, which is now telling a bit more of a story. We are combining all three, the data, the visualization, and the narrative, to tell this story about what the causes of food poisoning are, using the same data, but using these like a pictograph bar chart where the length of the vomit is the bar, and the amount of food poisoning based on the food eaten. If I could get another click, Ted. There's a lot of really, really great ways that data visualization tells stories. I thought I'd share the link here for The Pudding, which is a data journalism platform, and it's born digital. So there's a lot of really interesting journalism that it was you're scrolling down a website, you get bits of information that kind of build up over time to tell a story. So it's not everything at once, but a little bit at a time. But that's oftentimes quite sophisticated to tell a story in terms of the technology that it uses. But you can also be using, one more click, Ted, please, some pretty simple technologies that are very easy to learn. So I thought this was a nice example, especially for today, since it is Remembrance Day, to look at the different casualties across Toronto from the Second World War. And so a journalist had created this map through Google Maps. And so it's a free platform, open source, to use, I think, at least part of it. And then instead of just doing plain dots, the data journalists added a little bit more information through and a story through the use of the colors. And in fact, the little dots on the inside of each point. So each point is mapped to a specific address. And it looks like poppies. So we've got a field of poppies forms to give remembrance and thanks to those who were lost in the Second World War. So this is a beautiful story, I think, that resonates without a lot of technical know-how necessarily needed. If we could again go, Ted, to the next. We also have the idea of creating data stories through physicalization. And this can be done in many ways and has been done throughout time. I thought I would call out the Yakama time ball, especially because these are created by women to tell the story of their lives. They act as a personal diary for the Yakama Native American tribe, where they use beads and knots strung onto strings of hemp to be able to show their life story. And I thought that was very resonant, and as do many, because a lot of really interesting research has been done on these too. There's another type of physicalization that I think is interesting, where it's the idea of bringing in a participation with audiences. So I pulled out this example for a participatory physicalization of food impact. And so people can be creating their own story as a group, as a collaborative effort, sometimes over a small span of time, sometimes over a large span of time, to be able to tell a story together. And both of these images are linked to a list of other data physicalizations that have been created from like the beginning of time to now. If I could get one click, Ted. And really, data can be told through so many different mediums. I pulled this image out from a book that we have in our makerspace called Making with Data. It's also linked to an online copy on these slides here. And this kind of shows the different ways that one can tell stories. We've got data visualization, data physicalization linked here. Data physicalization is often defined as a physical artifact whose geometry or material properties encode the data. So where a data visualization encodes the data oftentimes through like a graphical means, like color or shape or size, we add in this physicality with a real life object when we're creating a data physicalization. But we can also use a lot of other mediums. We can do like data sonification, so using sound to be able to represent data, or there's like data edibilization, which I haven't actually experienced myself, but you could be encoding different aspects of things with the flavors of food, and a bunch of other different things that one can create. So we thought we'd share this just to ground how there's so many ways one can really be creating a story through data. So hopefully that piques your interest and makes you want to learn a little bit more about data visualization or physicalization if they're a little bit unfamiliar. But now we want to move into the challenge itself and some of the logistics that are important to know. So we think that the challenge, this is the first year we're doing it, but we think it really has a lot of great benefits for students. We want it to be a platform where one can be encouraged to apply and strengthen their data visualization and creativity skills. We purposely have it quite broad so that one can be honing their skills if they want to use a digital platform or doing it with by creating a physical object. We've got prizes from the York University Libraries leadership team and sponsored by a York University grant as well. So we'll have first, second, and third place prizes of varying worths. And then, of course, if one is a challenge winner, it also looks really great on one's resume. And then finally, but certainly not least, the challenge is going to feature a curated and juried exhibition of our top works at the Markham AMPD Gallery. So we'll have a photo of that, I believe, at the end of the slides, but that's on the first floor of the Markham campus. And it's going to be a really great partnership with our AMPD department. And Ted will talk a little bit more about how that's going to work. So this is what the timeline looks like. We launched last week. So our expression of interest form opened up so that any student could start to submit their interest. The form's quite short, but it does kind of encourage people to be sharing their idea early with us so that we can help you develop and create your data story, provide you with support systems within the libraries, suggest some resources tailored to your project. So we encourage people to be putting their expression of interest in sooner rather than later. And all of your ideas can be changing still, and that's completely reasonable and normal also in the creativity process. So today we're hosting the workshop, of course, and the slides and the recording will be shared on our website and on YouTube. And then we'll have our expression of interest form closing on January 19th and giving a few more weeks then for people to be submitting their challenge. So the challenge submission form closes on February 9th. And then we will have our exhibition opening on March 2nd and going for the next 3 weeks. We'll have an opening gala and an award ceremony on the first week of our exhibition too. So for eligibility, we invite and encourage all York University undergraduate and grad students to apply. They must either be a current student or have graduated quite recently from York University. Each student can submit up to one work of art, and students may choose to work in small groups if that's what they like, but we did want to note that prizes are then split amongst the group. So that's the brief overview, and we're very happy to be answering any questions about those logistics at the end of the workshop today too. But we want to launch into the challenge theme, which we hope is quite interesting and engaging for students. So the challenge theme is Land Star Machine. And if I could get the next slide. And it's really asking us how we can use storytelling with data to help us understand and cherish the land we inhabit while we simultaneously create and deploy increasingly numerous and complex machines. So I think it's pretty clear to almost all of us, if not all of us, that data and technology are now omnipresent in our lives, but they have a growing footprint that siphons more and more of our global resources. And yet there's often this kind of like abstraction or disconnection, particularly with data, which we say lives in the cloud. And that can sound quite nebulous, but in fact, it lives on servers that take more and more of our land resources. So we wanted to encourage people to be thinking about our connection to machinery or to land through our own lived experiences and cultures. So we wanted this to be quite broad and be able to connect people to the tapestry of technology in our local environment. So if we move to the next slide, really the idea is that students can use any data set that's related to land, machines, or both. It could be the environmental, the historical, the cultural, or the social factors of either of these or both of these topics. And really, that's the beauty of that star, the Boolean wildcard. This was a bit of our cheeky wink to library terminology. So the star or the asterisk is a wildcard in Boolean search terminology. So it can represent multiple characters. An example of that is that if you're to do LIBRAR star, it would search for words that start with that and have anything else coming after it. So that could be like library, libraries, librarian, or librarians. So that star represents any number of characters. And so we hope that people would be inspired to think land and machine, or land or machine, or land versus machine. So we know that sometimes there's so much data out there that it can be a little bit overwhelming to decide on what data to be visualizing. So we thought we would suggest a few data sets that students could use. So they're not limited to this, but it's oftentimes useful to have a starting point. And so we shared a few different examples in the website page and also in the slide here. So students could be using something like the SDG data, which there's a lot of everything from stories at the York University levels all the way up to the global level. So a lot of the SDG goals, like SDG Goal 6, clean water and sanitation, Goal 12, responsible consumption and production, and Goal 15, life on land, really correlate well to the theme of our challenge. But one can also be going to more local data, things like topographic data and the physical location of trees that the City of Toronto and the City of Markham share in their open data portals. They could be looking at the US Data Center Energy Usage Report, so getting data from white papers, or getting data from our government. So we link to some interesting data about the modes of commuting and the commuting durations that people have across Canada. And that one could be looking at Toronto data, or at like an Ontario level or Canada level. And then finally, students can be creating their own personal data set. So they could be visualizing their physical activity that they would maybe already have from their digital devices. Oftentimes smartphones will be tracking their number of steps or the number of hours that one spends on the device. Or one could be going out and kind of collecting the data more consciously or more slowly. So for example, collecting data about animals you encounter and you take photos of in your neighborhood as you're going for a walk or going from school to home, and vice versa. So to go and explore a little bit more about that, we thought that it might be useful to share some examples of what others have done with these data sets. So here is a still, it's just a screenshot, but this visualization actually is scrolly telling. So as one scrolls down the web page, you get an interactive visualization. And so this shows that the SDG 6.4 goal. It's about the strains on freshwater resources, and it will show how much of our water on Earth are really non-fresh water, and how little of it is actually potable for humans. Next. This is a nice example of a winner, actually, from the University of Colorado Boulder's data visualization competition. And so they use the data set of their trees on their campus, but we could be using instead the data that comes out of the City of Toronto and the City of Markham to be exploring a little bit more about the facets of data about trees. So everything in this case, comparing the coniferous and the deciduous trees especially, and the different of heights and the different amounts that there are of these two types of trees. So the student used this big data set and focused on a pretty narrow example of comparing deciduous and coniferous trees. One can also be inspired by a lot of the temperature data physicalizations that exist out there. So a good example of data physicalization that's become quite popular is the idea of taking our temperatures as it changes over time Sometimes it's like this, where we can visualize a whole decade's worth of data. Sometimes it's kind of on a day-by-day basis. So you add, say, one row to your crocheted blanket to represent that day's temperature. But in this case, it's kind of doing a retrospective. So looking from January 2013 to December 2023, or well, maybe September 2023, to show how the data or temperature changed over time. And so he actually used the fallen leaves to represent the data when it gets hotter and when it gets colder, and then took a photo of it and brought it into a digital editing tool to add some of those digital elements, like the notes on the right about how the global temperatures were majorly influenced in 2016 by the strong El Nino conditions. If I could get one more. Yes. Thanks, Ted. Or one can create their own. So Lana is going to kind of explore this more with us very shortly, but we thought we would share about how you can use data of your own technology. So for us, we don't expect all students to have this, but for us at York University Libraries, we have several makerspace 3D printers. And so Lana created this visualization that takes the amount of X, Y, and Z axis prints meters, and then she created these parametric forms using that. And then right now they're in digital format, but soon they'll also be created as a data physicalization, so creating 3D prints of these parametric forms too. Another example of a data set that was created by a student is this example by Nicole Nguyen, who created a fourth year project for her like AMPD capstone, essentially, that 3D printed balls, black balls to represent the carbon footprint of various technology uses. So things like how many text messages they sent in a day, how many hours were spent on social media platforms, how many emails they had archived and saved. All of that generates data that needs to be stored, and that takes carbon dioxide and creates carbon emissions to be able to store it in a data server. So she created her own data by conducting this study with 10 participants. If one doesn't want to create their own data set or use the ones that we suggest, they're also more than welcome to find their own options. We have a data and statistics libraries research guide that we use in many different use cases and encourage students to look at oftentimes, but I pulled out a few data sets that related to different topics that were particularly relevant to the challenge themes. So things like energy and resource extraction, environment, food and agriculture, all of those would fit well within it. And we link to data sets that are both at the Canadian level and at the international level in this guide here. There are other resources too. Of course, I always start with a library guide because I'm biased, but there are lots of really great places one can be inspired and find data from. So I mentioned before that the City of Toronto and the City of Markham have data about their tree locations, but they also have hundreds of other data sets because government bodies in general have open government mandates. And so many of them have their own open data portals that anyone can go in and download the data from and then use to their heart's content. There's also other repositories, particularly for research data that can be really useful. So Borealis is a Canadian research data repository. ICPSR is an international one that includes Canadian data. And this is a place where researchers will share the data that they create in their own research process so that there is the ability to reuse the data by themselves or by others and to share it more widely in the spirit of open data and open science. And then I linked to a couple other places that I particularly like. I like Data is Plural, which is an archive of, as they say, a useful/curious data sets. And then the Nightingale Journal, which has a lot of really great inspiration and articles on different various data sets. And particularly, they're good at exploring the different stories that others have created, either using data visualizations or physicalizations, and kind of a breakdown of the process. So that temperature data through leaves is a Nightingale Journal article. So we'll go now into the process of making it a data visualization or physicalization. And first, I think it's now going to be talked a little bit by Lana about her making process.
Hello. Hi. So first of all, very excited to be part of this project, and I really appreciate this opportunity to allow me experiment and also learn while doing. So at the first place, when I was like considering how to build up my very first data visualization project, I considered to collect data from my daily activity. And I thought that my daily activity is mostly in makerspace. So I started collecting data, 3D printer data, as the input for my 3D modeling. And so here on these two images, you will see those are the screens, LCD screens from the 3D printers we own. Those models are Prusa XL. And there's a feature in the machine that will provide you very detailed statistics about the machine. For example, here on the second picture, we'll see the x-axis, y-axis, z-axis, and it gives you all the total amount of traveling of how the machine already done. And the total amount of filament we already used. For example, here it says 2.5 kilometers already. So that's very impressive. So I collected all this data with the help of Makerspace coordinator, Jacob, who's already been collecting data from the printer. But what I did was I added more data to it by like reading more details through the machine. And on the right-hand side, you will see the final result of my parametric 3D modeling. I generated this four data towers based on each model of machine, each model of 3D printer. There are Prusa Core 1, Prusa Mark 4, Prusa Mini, and Prusa XL. Yeah, Ted, we can go to next page. Yeah, so here we can get a closer look of all the data we've been collected. And here you will see is categorized by the type of printer, the printer's name, print time, print meters to changed, XYZ axis. And also we need to keep the date acquired on it so that next time if we collect more data, we know how much time has been passed in between. And the final the last column says the speed for the machine. Yeah, that's the data collecting process. And since I'm not a professional data analyst, so I asked help from AI to save me some time on working on this project. So I borrowed the superpower of AI, ChatGPT. I basically just download the spreadsheet and feed it to ChatGPT and asked for a summary and also analysis of all this data. And here, this picture already showed me how each data was assigned to, and how and the numbers are basically the average, taking the average of all the data I have been collected. For example, for minis, I believe we have more than 10 machines. We have more than 10 models of minis. So these numbers are taken the average of For example, the radius is the average of all the axis direction traveling on the machine. And here it gives me a very clear form to tell me all the numbers I already I need to use to build the model. However, at the first place, you need to give AI a script. That way the AI knows like what to generate for you. For example, I need to previously assign relationships between different data and the design element. For example, if I here the longer print time, the taller tower I want to see, and faster speed means more twist, and more distance means like larger radius. Yeah, so that's the part I done for I tell ChatGPT like how to analyze my data and how I want to see my data being visualized. Okay, we can go to next page. Yeah. So after the first experiment of parametric 3D model, I found the process is actually very intriguing. Because before this experiment, I mostly use regular 3D model programs. For example, Fusion 360, or a more beginner-friendly use Tinkercad or FreeCAD, things like that for industrial designs or product designs. But started with parametric 3D model workflow. I found this process is very efficient, that so long you collect data and get this data analyzed and ready to use, this data can actually be the input for your workflow. That means you're building a logic for the program to understand. And this workflow will automatically update when the data change. And also the final product, like the 3D model, will also change accordingly. So that process is really impressive for me. And I found there are several benefits of this process that when it comes for me to produce different designs, but based on the same workflow, I found this process is very helpful. For example, I built all 4 data towers based on the same workflow. The only thing different is the data I use to input. I found the process is very easy to adjust. And so I did a little bit experiment with different design variations, and also saved me a lot of time. I don't need to rebuild each model from scratch for any changes. I can just use the same workflow, but apply different data inputs for each design. And the final model, the final result is really precise and beautiful, and also it's data driven. So, which means it's very relevant to my daily activity, and it speaks to the idea of this data visualization project. And also at the very end, when you created the 3D model, you can export it as not only as 3D model, you can also export it as 2D images for poster designs, for graphic designs, and so forth. So you can do a lot of things with it. Yeah, let's go to next page. Yes. So here's a video. I'm gonna show you guys the process of how the parametric 3D model workflow work. Yeah, so on the right-hand side, that's Rhino, and on the left-hand side, that's Rhino, and right-hand side is a plugin called Grasshopper. So as you can see, if I pull on the number sliders, the model will change like timely. So these first two sliders impact the radius of the models. And as you can see, this one controls the height of the model. Yeah, This one also controls height, but a little bit different. It controls the distance between each step. And how much it twists. Yeah, this one is very interesting that the larger number you apply, the more the tower will be rotated. Yeah, same as this one, but a little bit different. Yeah, all these numbers are actually mutually impacted. Yeah, if I adjust the number on the left-hand side, this number will change as well. Yeah, so that's the workflow. Okay.
Thanks so much, Lana, for sharing the workflow of how you created it. I think it's always so cool and a really great way that we think other students could be applying data physicalization as well and taking data that's maybe super relevant to them or that they think is interesting from the ones that we've proposed or that others have created. And they could be following a similar process of using Rhino and Grasshopper and creating a really beautiful work of art that is a little bit more abstract potentially from the other visualizations that one might create. But I think the beauty of something more abstract is that it draws people in and has them sitting a little bit longer with the data and the experience of understanding the data. But that's just one way one could be doing it and creating their data visualization or data physicalization. But we thought we would share at least a general process of how to make one so that anyone can be applying a similar process, whether they're making a digital or a physical work. It always tends to best to be starting with the purpose, the audience, and the context. So in Lana's case, the purpose was to be exploring the 3D printed data, but also to be creating a work of art that is a little bit more aligned with her background, which is in sculpture art, especially. In the case for others in this challenge, it might be good to be thinking about how, if you want to be participating in the exhibition as well, how that is conceived so that it could be either digital and understood on our screens or physical and be able to be supported in kind of a gallery environment. Then one needs to collect, explore, and clean their data. Sometimes the data that we create or that we find online does need a bit of time to glean the insights or make sure that the data is structured in a way that we can use it for our visualizations. Step three is kind of selecting the visualization type, and sometimes it's the tool or the medium too. Sometimes one knows exactly what medium they want ahead of time, but sometimes it's a little bit more organic, even with that example of temperature data, for example. The idea of using fallen leaves kind of occurred in that creativity process phase where they're incubating an idea and trying to decide what medium tells the best story, is aligned best with data. So in Lana's case, for example, because it was 3D printer data, it kind of made sense to be thinking about parametric form and then 3D printing the data visualization too, since it aligned quite well. The iteration phase and the testing phase, step four in this process is always really important, particularly when it comes to creating something physical too. And so we really encourage people to reach out to us as well. And we can be supporting them if they're making something physically in our makerspace, or if they're trying to figure out if the story is landing with the audience in the way that they intend, since sometimes there's been many examples where designers or creators have a story they want to tell, but it gets obfuscated for whatever reason, so it doesn't land with the audience as they sometimes intend it to. And then finally, the last step of this process is generally to share and to publish the visualization. Sometimes that means making sure that it's shared online. Sometimes in this case, it's probably best if it's shared and saved to like a USB key or something so that it can be displayed in the gallery without a lot of Wi-Fi dependency. But we do also have the research guide on data visualization created within the libraries that breaks down this process more so on how to create a data visualization. So we have that linked here too. I thought I would just explore a little bit more about the process of making a digital data story too, since Lana so kindly shared the physicalization process. But in this case, for a digital one especially, I thought it would be interesting to show this example that comes from an organization called Storytelling with Data. They also publish books that I'd highly recommend. And this idea where sometimes that iteration phase is really important. So they came with this case study is essentially created by a real life makeup company, and they wanted to be able to share with their stakeholders a little bit about the different makeup types or products and kind of the changes over time. And so they started with this graph on the left-hand side that is a line graph. It's kind of weird to read. You can kind of see these changes over time, but the story could be tightened up because the idea is to show the biggest decrease observed over time in this case. And so on the right-hand side, we can see that was a lot of iteration done by the consultant who was making over this graph. So they created all these different forms of visualization, some bar charts, some column charts, some dot plots, some scatter plots, to be able to showcase that difference because that was the main hope of the story. So if we can go to the next slide, this is the final result. So after the graph makeover, they decided that the best way to tell this story was actually to be able to tell it in 4 different slides. So it's to start with how the post-COVID makeup use is lower across all products. Makes sense as I completely gave up on makeup as well during the pandemic. And then goes into the different products themselves and then focusing on their takeaways. So I thought this was a nice one to highlight that instead of having this one image that the graph type isn't really the best suited for their story. And it's a little bit too simplistic to be able to share the journey of a cross makeup use and what the takeaways are for marketing. They decide to split it up into 4 slides and to be able to show the change over time and highlight the data, even though sometimes it's looks quite similar, they have different takeaways per slide. So hopefully that gave a very brief overview to the challenge process or the process to create data visualization, I should say. But we want to go a little bit more into the challenge supports that we have as well, since certainly we are available and very happy to be supporting students as they're going through this challenge. And so the best way to do that is to express your interest to us, and then we can give you suggestions and keep you in the loop of how things are evolving over time and provide resources as they become available. So next slide. One consistent resource that is always available is the various library resources we have about data visualization. So I mentioned this before, but we do have a library research guide dedicated to data visualization. It looks like this, or this is one of the pages that also links to all the different books that we have within our collection that are related to data visualization. It also gives some keywords to find oftentimes books or ebooks or research articles, or sometimes videos too about data visualization. And so that's what this page is doing. And it's calling out certain books like Better Data Visualizations by Jonathan Schwabish or Storytelling with Data. That can be really helpful to get one started on the journey of creating data visualizations if they're new to it, and useful to kind of be able to iterate and tweak as well. I thought I'd quickly call out another resource that we have for data physicalization. A lot of what's in the library research guide in terms of theory applies as well to data physicalization, not just data visualization. But we do also have a small collection within our Markup Makerspace about data physicalization. So this book, for example, Making with Data, is a really excellent one to get inspired by and understand the process of how others have created their physicalization. So everything from the cover of this book to going into the process, kind of like how Lana did for her rhino and grasshopper physicalization. So if you want a copy of that book, you could just talk to our students, student staff, or Lana in the makerspace. I'm maybe going to, just looking at the time, not play this video, but we'll have it linked and available for folks to be watching. But this gives a great overview of all the different spaces and resources we have in our makerspace, everything from like Arduinos to 3D printers, laser cutters, sewing machines, CNC mills. I feel like I'm missing other things, but certainly our website is very comprehensive and has a lot of really great resources that we don't think students necessarily know about, but encourage them to take a look at. We also do have library workshops, so we have a link to our calendar here of the various workshops that we have and orientations about data visualization, data, or our makerspace tools. So we have an upcoming workshop, for example, on stamps in the print press, and then another one coming up in a couple weeks for 3D printing. And sometimes you might see that the orientations are very popular. And so if you're wanting to be joining an orientation or a workshop and they're full, but if you want to contact us, we do have a couple spots reserved for workshops, so we can be supporting you if you're joining for the challenge and need to join a makerspace orientation. We encourage you to email us at datalib@yorku.ca. That email's on the first and last slide, as well as here. So you can consult with us for many different things. If you want to be ideating or refining a data visualization or data physicalization, we encourage you to send us an email. And then we can triage to support you. So we might we might give you a reply via email, or we might suggest that you should book a consultation with us. So that's kind of like anywhere from 15 minutes to up to an hour to talk about your project. If it's data visualization, I'm oftentimes the best one to be contacting. If it's digital fabrication, it's Lana or others within the makerspace. And if it's kind of digital engagement broadly, Ted might be your best bet. But that's all to say that we're the people who are here to support you, but we don't expect you to know everything about what our roles are. And so that's why we have the datalib@yorku.ca email that we all look at and will triage and support. I do want to call out, though, that you can be dropping by the makerspace during our open hours to request support kind of on demand. Okay, Ted, you've got 3 minutes. I'm so sorry.
That's quite all right. I think we can get through it in that time. So I'm here just to close this up with a bit of information about the exhibition that will follow at the end of this once all the submissions are in. So as Alex mentioned at the beginning, this will be taking place at the Markham campus in the AMPD gallery, which is on the first floor, the ground floor of the Markham campus building. It is empty here in this shot, but it gives you a sense of the space. It is very visual. So even when the gallery is closed, you can still have pretty good sight lines into the space and into any mounted exhibition. There's nothing going on there right now, so that's why it's so empty. So just a couple of things up front. Just a quick overview. So the exhibition will be accessible to everyone from York University, but it is also accessible to the public. So members of the external community from York are able to come in and see the exhibit. Alex also mentioned this will launch with a gala event taking place during the opening week of the exhibition. And that at that time is when the prizes will be awarded by a panel of jurors. And the gallery will then have open hours with scheduled tours available for groups, and that will all be facilitated by our team here. So the important dates, they were shared at the beginning, but just to highlight these again, specifically with the exhibition. So it will run from Monday, March 2nd to Friday, March 20th in 2026. The installation period for exhibit items will take place, I believe this is the week or two after Reading Week, but it is from Monday, February 23rd to Friday, February 27th, and that will be by appointment. We'll make sure that we've got people here to support putting up the artwork, and then takedown will happen on just after the exhibition closes. Again, we will plan this out with you individually as well when that will happen. And then the gala event is scheduled tentatively for Thursday, March 5th from 4 p.m. to 7 p.m. So the breakdown of what will happen between 4 and 7 will be shared at a later date as we finalize some of those details. So just a bit about the actual gallery space itself. You can see the stats here. It's got a ceiling height of 10 feet. There are 3 walls, but we cannot mount things directly on those walls. As you saw, most of the walls there were actually glass. There are, though, 3 modular walls that measure 7 by 7 by 2 feet. And so that gives us 5 mounting surfaces and up to 7 plinths. We are still sourcing these, so we don't have the final details on those. You will get this slide deck as well. So if you want to take a closer look, this is just a quick floor plan and gives you some measurements of what you'd be dealing with, as well as where the like electric plugs are and Ethernet ports. So some guidelines, these are just estimates at this point because it's all going to depend on, well, for one thing, the dimensions of the plinths that we are able to source, as well as how many works we actually end up with being submitted. So we may have more or less space depending on how many pieces of work that we have to be displaying in the gallery. But in general, this is a good guideline to get you at least started in your thinking of what you'd like to make. So digital works that are going to be displayed on a screen should be in the 1920 by 1920 by 1080 pixel resolution. So these can be in portrait or landscape. And then as far as the physical objects, try and work with these dimensions that we've listed here. So for two-dimensional works that will be hung on one of the walls, we've got 2 feet by 3 feet. And then the 3D printed objects or 3D objects, they don't have to be printed, but three-dimensional projects should be 16 by 16 by 16 inches. And then if it is a freestanding or using your own display, can be 22 by 22 by 60, which is about 5 feet high. These, again, are just guidelines. They're estimated on the space. So as you start building these things, use this as a guideline to start, but get in touch with us. And if you want to exceed these, and we can discuss what's possible. So just before we end here, we want to go over just a couple things in terms of when you do start planning, to carefully consider those dimensions, so the height and the weight of your objects, if you're working in 3 dimensions, and then the installation method. So put some thought into how it will be mounted. If your work is too large or heavy, we might not be able to exhibit it in the space, just given the constraints that we have. So please coordinate it with us as early as possible, just so that we're in the conversation and we can come up with contingencies if needed. Secondly, consider the financial, technical, and feasibility constraints that you might be working with. So materials do cost a fee, so keep that in mind with what you're working with. Also keep in mind that you will have to transport this artwork to the Markham campus. So if you're not located on this campus or you're working somewhere else, you do have to get that to this location. And then think again about what those installation requirements are, and we're happy to work with you to figure out those details. So as I said, because you are responsible for transporting and installing your own artwork, it must be delivered by the creator in person. as well as installed. So we don't want to take responsibility for that. We want you to have hands-on because you've designed it and you know how you've put some thought into how it should be mounted. We will definitely be there to support the installation, but we want you to lead the way. And similarly, we would like you to take down the piece by your own hand as well. And again, we can provide some support with that, but you will again have to transport it. So that brings us to the end. I think we're just about on time. So again, the contact information is here if you do have questions. datalib@yorku.ca is where you can email us. If you have any questions at any point, we do encourage you, if you're thinking of submitting, to fill out that expression of interest form. So we'll be distributing more information through that once you've submit that expression of interest, then we were able to be in contact with you and we can send you some of those additional details as we have those things worked out.